4, polymorphism. In today's session, we are going to learn about pure virtual functions and abstract classes. Okay, to understand pure virtual functions, you need to understand abstract class, and you need to understand importance of pure virtual functions. You need to understand abstract class. Both the points are related with each other. So we are starting with the abstract class. A class that contains a pure virtual function is called as abstract class. A class that contains a pure virtual function is called as abstract class. What is the use of such class then? What is the use of such class then? We are going to learn about this pure virtual functions. What is the use of such class then? If we can't create object of this abstract class, it is used a base class for other derived class. Keep in mind, this abstract class is used as a base class for other derived class. All the common code in derived classes is written in abstract class. All the common code in derived classes is written in abstract class. Sometimes implementation of all function cannot be provided in a base class because we don't know the implementation. Such a class is called abstract class. Such a class is called as abstract class. Now we are going to learn about the pure virtual functions. Before that, keep in mind, pure is not a keyword like virtual. The virtual function has given the name pure, but pure is not keyword in C++. Keep in mind. You don't need to write pure anywhere in a program. Keep in mind, you don't need to write pure anywhere in the program. So these 2 points you need to remember with respect to pure virtual functions. What is pure virtual function? So this is the class A, which consists one virtual function, virtual void display in the public area, and you need to mention equal to 0. Equal to 0. Virtual void display equal to 0. This equal to 0 makes this function as pure virtual function. Again I am repeating, this equal to 0 makes this display virtual function as pure virtual function. And this is the way to make a particular virtual function as a pure virtual function in C++. Only thing is that you have to mention equal to 0. Equal to 0, which makes this function as a pure virtual function. And this must be a virtual function. If you are not mentioned over here and directly you are assigning 0, compiler simply gives you error message. To make it pure virtual function, you have to add equal to 0. Just I have said you have to add equal to 0. Then this function is called as pure virtual function. Then this function is called as pure virtual function. Keep in mind, it has no definition, that is function body. This function doesn't have any body. Semicolon indicates end of the statement, and you mention display is equal to 0. That is end of the function. Over here you have not written any body of the function. So it has no definition, that is function body. Keep in mind. A pure virtual function or abstract function, sometimes it is also called as abstract function in C++, is a virtual function for which we don't have implementation. We only declared it. Now you can understand a pure virtual function in C++ is a virtual function for which we don't have implementation. We only declare it. We only declare it. Pure virtual function is declared by assigning 0 in declaration. A pure virtual function is declared by assigning 0 in declaration. Just now we have seen. Y equal to 0. What it means, what it does. It indicates that there will not be any definition. No definition for the function. If there is no definition for the function, then what is the use of such function? Then what is the use of such function? You cannot define this function in the class, in this class. Therefore, it is called as pure virtual. Why it is called as pure virtual function? Because you cannot write the body of the function in that particular class. But you have to define this in all derived classes. But you have to define this in all derived classes, and it is compulsory. Compulsorily, if your base class contains virtual function, pure virtual function, then in the derived class, the body of that function must you have to write. It is compulsorily you need to write it. Then I am going to explain this with the help of code. So this is the project I have already created in this code block. So I am going to create one class A. Inside this class, in the public area, I am going to mention the display function, void display. Okay, and I will make this as a virtual function by mentioning virtual void display. Now you have to make it pure virtual function is equal to 0. Is equal to 0. So this will make this as a pure virtual function. Now save the program and I am going to compile it. There will not be any error message and warnings. We have just one class over here, and in the main have by default code hello world is present. Now what I am going to do over here, I am going to create the class B public A, and now just I am going to compile the code. Virtual display class B, and in the public area, not going to mention anything over here. And once you make this as a virtual display and your class is, you have derived this class A inside the class B, and you have created object of B bj. Now see, object of B, I have created class A. From this A I have derived class B and not mention anything inside this. And I have created the object of class B, and I am going to compile the code. So I will get this message. What is the message? Cannot declare variable object to be of abstract type B. Cannot declare variable obj to be of abstract type B. Why this error comes? Because once you mention virtual function in class A, and from this you have created the another class, that is class B, and you have not written the body of this display function in the class B. Then this class B becomes abstract class, and you cannot create the object of this abstract class. That's why this is the error message. Cannot declare variable obj to be of abstract type B. Now I am going to write in this public class B, in the public area, void display, void display. I am going to compile the code. Now there will not be any error message. There will not be any error message. And this is how you can write the display function. And once you derive a particular class from this, you need to write the body of this function. For time being, I am going to write one statement over here, and I am going to call this display function. Inside class B, inside class B in now I am going to write handle. Now I am going to call this display function. Vj dot display. And then compile and execute. So you will get this output inside class B in display function, and you will get the hello world message. So this is the way to declare the virtual function, and you have to make use of this virtual function in the derived class. Now again I am going to go to presentation. So why we need abstract class? Now understand the use of abstract class as well as pure virtual function. Suppose this is the class person. This is the class person, and these are the classes you have derived from this, from class person, class manager, class accountant, and class customer. Now one common feature among this class manager, account, and customer is to get the name. So I will make this get name as a pure virtual function over here, so that a particular class is derived from this person class. Will need to write the body for this get name. So here it is, manager will write the get name, accountant will write the body for get name. Similarly, customer will write the body for the function get name. Just make this as a virtual void get name is equal to 0, that is pure virtual function. Automatically a particular class, once you derive from this person to any subclass, then it will be compulsory for that class to implement this get name. Just now we have seen the display. Once we create the class B from A, we need to write the body for the display function. So this is why we need this abstract class and the pure virtual functions. Take another example, class bank. Class bank. From this, suppose you have derived class ICICI, SBI, and HDFC. So what is the common among all these classes is get rate of interest. Each bank will have a different rate of interest, so there will be a method which will take the input as a get rate of interest. So this common feature, common function, make it pure virtual function. virtual void get rate of interest is equal to 0. Then once you make it pure virtual function, then it is compulsory for ICSA class to write the body for get rate of interest function. Similarly for SBI class, compulsorily here that class need to write the body for get rate of interest. Similarly for HDFC class, get rate of interest. And this is why this is another example which shows this class bank is abstract class and which consists the pure virtual function. Pure virtual function present in the class, that class become abstract class, and you cannot create the object of the abstract class. But you can make use of this abstract class as a base class in your inheritance hierarchy. So whatever features you have learned in this language, you need to apply all the features according to the problem statement and need of the problem statement to be solved. As a programmer, this is your skill to which concept to be applied in the problem statement to solve that problem statement. Take another example, class shape. From this shape you have derived rectangle, triangle and circle. And keep in mind, suppose the common feature of all this, you are going to calculate the area of that shapes, then make that area function over here, make it pure virtual function. Virtual void area is equal to 0. Once you make it pure virtual function, then automatically a particular class created from the shape class need to write the body for the area function. Similarly, triangle need to write the body for area. Similarly, circle class need to write the body for the area. And each area, body of each area will have different logic. Here it is will have different logic. Here it is will have different logic. Here it is will have different logic. So this is the one example which shows the importance of abstract class and pure virtual function. Now these are some of the interesting facts. A class is abstract if it has at least one pure virtual function. A class is abstract if it has at least one pure virtual function. We can have pointers and references of abstract class type. We can have pointers and references of abstract class type. If we do not override the pure virtual function in derived class, then derived class also become abstract class. That's why in the beginning we get the